Now look, we need to first of all recall certain basics in probability, like the sample space. What's meant by sample space? The total outcomes. That is a set containing all possible outcomes. The set containing all possible outcomes. For example, if we toss one coin, sample space will be HT. If we toss two coins, the sample space will be H, 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 T, T, H, T, T. If we toss three coins, the sample space will be H, 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 T, H, T, H, T, H, H, T, T, H, T, H, T, H, T, T, and triple T. If we toss four coins together, the sample space will be one thing. If you notice, the number of elements in the sample space is actually 2 raised to the power number of coins. There is one coin, 2 raised to the power 1. Two coins, 2 raised to the power 2, 4. Number of elements in the sample space, 2 raised to the power 3. That is 8. Here, how many possibilities will be there? 16. So write 8 times H and 8 times T. Then 4 times H, 4 times T. Two times H, 2 times T. One H and one T. So number of possibilities is equal to 16. So in general, we can write number of elements in sample spaces 2 raised to the power n, where n represents number of points. Am I clear with it? So these are the examples. These are the sample space in case of a coin only. There may be die, there may be playing cards. So we'll discuss them all. So this is pen आप इसको note करो. Now look for it. In case of a die, the sample space is
6.
no. Sample space is 1, 2, 3, 4, 5, 6, and number of elements in the sample space is 6. If there are 2 dice, sample spaces no. 1, 1, 2, 2, 6, 6. And S is 36. In case of 3 dice, it is
1 1 1 2 6 6 6.
2 triple 6. And number of elements in the sample space
6 raised to the power 3.
6 raised to the power 3. So in general, we can write number of elements in the sample space is actually 6 raised to the power n, where n represents number of dice. Okay. Achha, one thing more we can, like in case of 2 dice, how many doublets are there? How many doublets are there?
So
Not
6.
dice. It will be 6. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. How many triplets? 6. 6.
Plus
Triple
6.
1, triple 2, so on. What is the minimum sum in case of 2 dice? 2. Maximum sum in case of 3 dice? And maximum sum? 8. Look it up. In case of playing cards, how many cards are there?
52.
Out of 52 playing cards, there are 26. 26.
Black.
Good. Out of these 26 red, there are 13 hearts. 13. Out of 26 black. And 13. Shapes तो सबको पता ही है. Hearts तो बच्चा जानता है आजकल. Diamond, spades, spades, spade, and clubs. Out of hearts, there is one. Then, 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 then. क्या बात है? अच्छा दिवाली आ रही है ना? Got it. Same here, same here, same here. So these four are known as honor cards. These three are known as how many honor cards in all? 16. How many? 4 into 16, eh? 4 into 4, 16. Uh, how many face cards? 12. How many numbered cards? How many kings of heart? हाँ kings of heart तो one ही होता है जी. How many black kings? Black queens? How many 10 numbered card? बस ठीक है नोट. सब एक्सपर्ट हैं. For questions like this, we'll be needing the knowledge of tree diagram. Tree diagram is we represent the solution in terms of a representation, right? That is a pictorial representation. Like if we toss a coin first, it will be heads or tails. After that, we are rolling a die. On a die, we can have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the sample space would be H1, H2, H3, H4, H5, H6, T1, T2, T3, T4, T5, T6. Is it clear? There's one more thing. We call it space diagram. Tree diagram can be used for n number of things, but the space diagram can be used only for two things. Like we write one possibility row wise, another possibility column wise, and then we put up crosses for each intersection. This point, that is, each cross is actually representing a point in the space, and each point is actually representing a sample point. If you notice H1, H2, H3, H4, H5, H6, similarly T1, T2, that is this also we can write by for this. Am I clear with it? That is the two representations, tree diagram and space diagram. Both of us help us to write the sample space of any event, right? So this is called note कर लो, बस ये basic knowledge है. Next thing is the event. Event is the favorable outcome. Favorable outcome or the desired outcome. जैसे सारी possibilities हमने वहां mention की थी. जो desired outcome होगा, जो desired sample points होंगे उसमें से, that will constitute the set event. Like for example, we were saying getting a prime number on a die. Getting a prime number on a die. What will be the event set here? 2, 3, 5. Getting 2 heads when a coin is tossed twice. Getting 2 heads when twice. Exactly. When it is not at least or at most, it is exactly. So this will be, बताओ कौन कौन सी possibilities आएंगी? 2 heads when a coin is tossed twice. It will be H, H, T, H, T, H, or T, H. Note. Next is types of events. Simple event having only one sample point. That is a type of events which have only one sample point are simple events. Can you give an example? Getting 6 on a die. So definitely a simple event because there will be only 6 on this. Compound event. In short, we can write this as ns should be greater than 1. Then it will be a compound event. For example, tossing a coin. Tossing a coin is an experiment, and getting outcomes on that is the event. What the difference? So this is getting, like for example, just अभी हमने किया था, getting one head on 2 coins when a coin is tossed twice properly. When a coin is tossed, so this will be HT. So this is a compound event. Do you know about mutually exclusive events? What are mutually exclusive events? The events which have nothing in common. That is, if A intersection B equal to null set, then the events will be mutually exclusive. So for mutually exclusive events, it is mandatory that there should be nothing in common. For example, if A is getting an even number on a die, B is getting an odd number on a die, right? So these two events will be mutually exclusive because here it will be only 2, 4, 6, and here it will be only 1, 3, 5, right? इसको हम ये भी बोल सकते हैं that is this particular example is a perfect example for even mutually exhaustive events. For mutually exhaustive events, the condition is A union B equal to the sample space. If all the events together form the sample space, they are mutually exhaustive events. So, for example, 1, 2, 3, 4. B equal to say 3, 4, 5, 6. And we are talking about a die. So if you see A union B will be equal to 1, 2, 3, 4, 5, and 6. So it is forming the sample space. So one thing that should be understood, it is not mandatory that for exhaustive, it is exclusive also. An event can be only mutually exclusive. An event can be only mutually exhaustive. Like for example, अगर यहाँ पर 6 नहीं होता, so these two events would be still mutually exclusive, but not mutually exhaustive. यहाँ पर they are mutually exhaustive, but not mutually exclusive. There can be events which are mutually exclusive as well as exhaustive. जो दोनों होंगे. Mutually exclusive and exhaustive. So, for example, that is this particular example is a perfect example for mutually exclusive as well as exhaustive. Last, complementary event. Complementary event is actually non-occurrence. The non-occurrence of the event is its complementary event. So if E is getting an even number, complementary event will be getting an odd number. If E is winning in a situation, complementary event will be losing in a situation. In an experiment only, right? Points. Look for it. The probability of occurrence of an event is NE upon X. That means number of favorable outcomes upon total outcomes. Probability of non-occurrence of an event is 1 minus C, 1 minus occurrence. The probability of an event always lie between 0 to 1. Probability of an impossible event, probability of sure event, right? Impossible 0,